Good evening, everyone.
Good evening, sir.
Good
Hello.
evening, sir.
How was your Diwali?
Good evening, sir.
It was good, sir.
Good.
But then we had some week 7 assignment.
Uh, but still, we are in 2 weeks 7, right?
No, sir. Actually, graded assignment date has passed for week 7. This session was like not conducted at time.
Okay. Okay. But I have actually 2 days back, I had joined the session, but nobody has come.
Actually, sir, so 2 days back, from 2 days back, like 4 days back,
Huh,
we had this session in our calendar. So we joined earlier and
huh,
nobody came.
huh.
So in your calendar, this was like 2 days back. In our calendar, this was 4 days back.
Okay. 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 So, some miss. Oh.
So we joined and we waited for like 1.5 hour
Hmm.
for some instructor to join,
Yes,
and
sir.
nobody came.
And in between, we discussed. He explained.
Okay. In Friday, actually, I joined and nobody was there. So I was there like for I think
In
20,
our
20.
calendar, no.
Hmm.
It was on Wednesday, sir. On our
It was
calendar,
on
it was on
Wednesday.
Wednesday.
Yes, sir. Even
Okay.
we spoke the same. Usually, it was on Friday.
Hmm. Okay.
Sir,
What?
yesterday revision session notes please upload. It's 5 and 6.
Which one?
It's 5 and 6 revision session was held yesterday. Please
Yeah, yeah,
upload the notes.
yeah, yeah. Okay, fine. So, what should we discuss today then? Week 7, because today's session is written here as open session for
Yes,
week.
sir.
Week
Yes, sir.
7
We want to
all the
discuss week 7
concepts of
only because
week
concepts
7.
are not quite clear to us.
Yes.
Okay, sure.
Mainly, sir, if you can like since date for deadline for graded assignment has passed,
Huh.
maybe you can pick up some questions from graded assignment itself and solve them for us.
Grade
Yes,
assignment.
sir.
Okay.
Uh,
One
s-
more. Okay, one
Hello,
minute. Yes.
I'm audible, right?
Yes, you're audible.
Yep. So, sir, I understand that people, I think they want to understand week 7. They have some queries, but I think
Hmm.
also it would be wise if we also cover some part of week 8. Why I'm saying is because we have the deadline for the next graded assignment on 2nd of November, and I think that is we only have like
Actually,
2 or 3 days.
Siddharth, actually, that Shrikant sir told us that maybe it will be pushed to Friday,
Oh,
so that we can focus on week
No, no, I
7 for
don't
now.
think.
As we
The graded assignment date will not be changed. I think so. If sir agrees,
so
then we can go.
Shrikant sir told us earlier in yesterday's session that
mhm.
they will try to push it to Friday so that we can cover week 7 also, which was missed due to this
Okay.
session
Sir, what do
for
you
this.
think? I mean, if you're aware of that, if you can
Okay.
confirm.
So, okay, just wait.
Smile, some background noise is coming from your end. Please check it. Or if you can isolate yourself.
Okay. So, yeah. So I talked to Srikant. So he's saying that we can, maybe we can change the deadline to Friday, but it's not confirmed yet. So, and today we are going to actually look into week 7 because the upcoming sessions will discuss week 8. So, and a lot of you wanted some questions from weeks and grade assignment to be solved, right? So, what
Yes.
we can do is maybe I will share you that. I think it will be good for you also to practice some questions from week 7 solve with us. So anyway, you haven't seen the solve with us questions, right, for week
Yes.
7?
Yes, yes.
No,
So what I'll
No,
do
sir.
is, yeah,
no solve with us session for
so
weeks.
correct. So what I'll do is, we will see questions from solve with us, and mostly the solve with us questions will be very,
Yeah,
similar
they're
to
related
the
to
model.
graded assignments, sir.
So
Yeah.
it's better that you will also get the practice, and we'll discuss some questions there itself. Uh, does this sound good? So weekend
Yes, sir.
we'll do in next session, right? So anyway, your
Sir,
quiz also is coming, so it's better practice for you also to again solve some questions from week 7. It's fine.
Yes, sir.
sir,
Yes,
please
sir.
upload the slides of this solve with us week 7 and also the
Sure, sure,
yesterday revision session of 5 and 6.
sure,
It
sure.
will help us to actually solve the mock.
Okay,
Otherwise, it will create problem. Not yet uploaded.
okay, sure, sure. Yeah, I will. After this session, I will talk to again Srikant, and we'll try to finish. So week 5 and 6, it's not there, right? You're saying? So 7 I'll upload. 5 and 6 I will check.
5 and 6, yesterday there was a revision session. No recording is available also. Sir has confirmed
No,
that tomorrow,
recording, recording.
today he will upload, but not yet
No, no,
available.
recording he has pushed actually, but yeah, maybe by so since
Notes is required from the
okay, fine.
recording. There is a 3.5 hour recording. Notes is important.
Okay, fine. Okay, just give me. Okay, I'm sharing my screen, so you can join the peer deck, and then we'll start solving some questions. Okay. All of you are able to see my screen?
Yes, sir.
Okay. So yeah, so this is the this is the code for the joinperi.com. You can use this code. It's PWMOBI. Okay, weeks 5 and 6 recordings. It is not pushed, like Srikant has given to the team, the ops team, but it is not, I think, made available publicly.
But tomorrow, within 12 o'clock, the mock test will be vanished. Mock test submission link will be vanished. Then it will.
But tomorrow you'll get that thing. So tomorrow is working day, right? Monday, so you'll get it by morning. Tomorrow, I
No,
think it's the deadline for mock test. I
for
think it is.
the working, it is possible. It is problematic. Please upload by today.
Okay, well, I'll ask. Actually, see, it's not
Today
in our
night
hand,
will
right?
will take time to solve it because
Yeah.
for the working personnel it is problematic to solve in the working within
Okay. Okay. Let's see what we can do, and maybe we can push the deadline for mock test also. Let's see. Okay. So 15 students has joined. So let's start. Others who haven't uh, like joined through this peer day, you can use this code, which is PWMOBI. Okay. Okay. This is the first question. Question 1 is, let x1 and x2 be two IID random variables with mean mu and variance sigma square. So these three are the different formulations of sample mean. So A is x1 plus x2 by 2, B is weighted average, so it is 0.1 times x1 plus 0.9 x2, and C is equals to x2. So these three are the different formulations of sample mean. Now choose the correct options from the following. Option A is variance of A is less than variance of B is less than variance of C. Option 2 is variance of A equals to variance of B equals to variance of C. Option 3 is variance of A is greater than variance of B is greater than variance of C. And option 4 is variance of C greater than variance of A and variance of B. So what you have to do is you have to find variances for each of these formulations. So you have to find variance for A, variance for B, and variance of C, and then you have to compare these variances. Okay.
Hello, sir.
Yeah.
Sir, one request, sir. Practice book of week 6 has still not been released, I think.
Yeah, some in the
Yesterday,
yeah, I understand. So actually, we are making some changes in that. So once it's completed,
okay.
we'll upload. Okay. So it is not yet finalized. So we are doing it.
Okay.
Okay. So yeah, is it completed? This question.
Yes, sir.
Yes,
Okay.
sir.
So first of all, how to find variance of? Okay, we'll see the solution. I think. So we'll see first responses. Okay. One. Okay. Most of the people have said A. One or two said C and D. Let's see which is the correct answer. Looks like A is the correct answer. We'll see. So X1 and X2 are IID X, right? And expectation of X. So population mean is mu and population variance is sigma square. we have given three formulations for the sample mean. First is A, which is equals to x1 plus x2 by 2. Second one is B, which is 0.1 x1 plus 0.9 x2. Third is C equals to x2. So variance of A equals to what? Variance of x1 plus x2 by 2, right? And we know from the properties of the variance, so variance of C into anything is equals to what? C square into variance of that random variable, right? So C here is 1 by 2. So I can take 1 by 2 out as 1 by 2 square into variance of x1 plus x2, right? And since x1 and x2 are independent, we can write variance of x1 plus x2 as variance of x1 plus variance of x2, and that constant is outside, which is 1 by 4. So 1 by 4, and I know we know that x1 and x2 are IID random variable which belongs to a population X, which is having
So these are x1, x2 are sample means, no?
x1, x2 are not sample means, right? X1, x2 are the IID samples. Sample mean is so these three
So
formations are
it is,
there.
so this sample is only one sample, that is one element, or this is corresponding to some elements in the population.
X1 is a one sample taken up from the population, so it can contain different
No, no,
uh,
one sample is taken, but what does x1 denote? Matlab, just like we see that x bar, there are various sample
no, no,
means,
no, not
but
X bar. No, 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 not X bar. These are the
that
elements in the mean, right? So elements in the uh, so it can
X1
be one
represents
element.
so one, a variance of one element, how can we define, sir?
No, no. So element of one element means what I'm trying to say is variance of x1. X1 is a sample taken from a population, right? So it can have uh, uh, different uh, you know
Sets, na? It
number of
is set
elements.
of elements.
Yeah, set of elements. Yes. So but
Yes.
it is not a sample mean for that set, right?
It is just a sample taken from a
Correct. Correct.
sample, and from there we are picking some elements, and that is
Correct.
but the function is not given that how x1 is coming and how x2 is coming,
It's not
but
needed, right?
only the x1 and x2 is
Sir,
same.
action is
Both are
not like
IID.
action is one observation from the sample, right? X2 is another observation from the sample, right, sir?
It's not like that. So
No,
it's
no,
not
no, no.
only one
It's not like.
observation. It can have different observations. So if you have gone through the lectures carefully, the sir has
But
defined some
but
sampling.
as a,
Uh,
yes, sir. But as the samples will change, so the value of x1, x2 will change.
yeah, it can change. Yes.
Yeah, but they are still one observation from the sample, and it varies across the
No,
different samples.
so I just want to know that we have taken two samplings from a population sample, and from there we have arrived to we have taken x1 and x2. These are not these are matlab just few
These
samples
are just the
taken from a
variations of
population.
x, values of x, just for two sample, 2 points in the sample.
See, x1, what does this x1? This is a random variable, right? First of all, x1
It
is
is a
what?
random variable.
Correct.
So
So
that
random.
so
Random.
likewise, sir, the sample mean was also a random variable.
Correct. So, but it is not mentioned here. It is a sample mean, right?
Uh,
So
because we
let's
know
say
how sample we can define how what is the sample mean.
Hmm.
It corresponds to some sample from a population sample. That is what I am trying to say, that x1 is corresponding to some sample taken from the population,
just a minute.
right, sir?
I will tell you this. It's week 7, right? Is it visible? These slides are visible,
Yes,
right?
sir. Yes,
Okay.
sir.
Yes.
Okay.
So like here, sir.
Just a minute, we'll see.
Yes, sir.
So okay. So what is sampling and what is sample here? So you can say that.
This sample.
Uh, so
This is a set of samples. This is one sample taken from a population sample, and that is corresponds to. It has 20 elements in it.
so
20,
what is mentioned here? Each sample in each sampling is an observation of a random variable, right? So that means so x1 equals to something is there. So there is this is one of this is sample of sampling, right? But at the end of this lecture, maybe sir has said that it is very confusing for us to say sample and
yes,
sampling. We are considering sampling also as sample. What I
right, sir.
remembered correctly.
Yes, yes.
You
He
can
repeatedly
think
had said that.
so you can think entire thing as a sample also, because see, if I'm saying that x1 is a random variable, at a time it will take only one value, right?
So here x1 is 1 and x2 is 0. It has two random variables.
Where is one
In
and two?
sampling one, in
Ah,
sampling 1, 2, and 3.
no, x1 is okay. So
Yeah, we can say like it that
So
there are
here
two
we
x1
have
random
x2
variables,
up
one
to
and 3.
20, na, sir, and
here we have
x1 is 1.
x20, right? We have 20 elements, so x1, x2, x3, x4, x5, x6 to x20, right?
Yes, and first, okay.
Consider this as like this: x1, x2, x3, like this. Or you can actually consider it entirely, so you can consider, and you can say that this is the sample taken out. So I'm not sure like where it is written. uh,
Yes, it
Can
is
you
same
here
thing, na, sir. There
define?
will be 20x and x1 is equal to 1, x2 equal to, they are taking the specific values for that sampling.
so you see here capital x1, x2, xn, what are they? They are,
Idea
no, that is okay, but what is x1? X1 is completely a
1.
A
sampling,
sample
right?
from a sampling.
It's a sampling. No, it's a sampling. And given data, if you say small x1, x2, xn, they are from one sampling instance, right?
Mhm.
Yes, sir.
So
So please go upside.
hmm,
That's why that's what I'm taking. Sir has written the X a PMF of X, right, sir? So one sampling we
where
have taken
hmm,
here. ID column here is the PMF of X.
that is okay, right? This is
So
Bernoulli
so
triads
these are
PMF.
the X1 to Xn. These are the elements of one sampling.
So capital X1 is one sampling, okay, and x1, x2 to xn are are from one sampling instance. So in each sampling, so for example, consider the sampling one as capital X1. Okay. In that we
Okay.
have 20 elements, right? These are, you
Okay.
can consider small x1, small x2, like this,
Yes.
right?
Yes. Yes.
You can think
That
of
was
like that way also, or you can
sir.
think
So
of,
here sampling one, two, three are you trying to say that sampling one is X1, sampling two is X2, sampling three is X2,
yeah, you can think
and
of like that.
all three are the IADs.
Sir,
All
how
are,
is it possible? Sampling 1 is not x1, sir.
see. So what is this sampling one? What is this? You can tell me.
Sir, what?
Uh,
Okay, so what I understand is, sir, that x1, x2 up to x20 are 20 random variables.
okay, that is
Okay,
fine. That is
and
also okay.
yeah,
Correct.
and each time you take these 20 data points from the population randomly.
Hmm,
These are defined,
hmm,
so they vary across different samples that you are taking from the population.
hmm.
And
Okay.
x small x1, small x2, small x1 are just values that it take in one sample to represent. Its value will change across different samples, so the in one of those samples this is the values that it is taking for one sampling instance.
So given data is small x1, x2, x1 from one sampling instant, right? So
Yes, so the
what?
x1, this
Huh,
small x1 is one for
huh, yeah. Let's say
samples on above.
in this case it is small x1, this small x2, this small
Yes.
x3, right? And
uh,
what about this capital X1?
Capital x1 takes the value small x1, no, sir. Capital x1 is a random variable.
Yeah. So capital X1 can take these values, right?
Yeah, capital X1 can take 1 or 0 across these three samples,
Correct.
and in
Correct.
one of the sample it
It
is
is
taking 1,
same.
in another it is taking
So we
0.
can say
Correct.
that x1 can take values from a small x1 to a small xn.
No. See, capital X1 is actually it's either a PMF or it's or maybe because it is taking it from we are taking it from a distribution, right? Okay, let me
And that distribution comes from different samples.
one minute. One minute. Actually, you should not. It's not that confusing, if you think
It's
so.
not confusing, but the question, when we look at the question, it gives some
Yeah,
different sense.
no, you're thinking. So no,
Because
no,
what we are reading here, sir, we are not we are reading we are studying the samples,
mm,
and what we are asked in the question, it must be from samples only. Then only we can
let's see.
calculate those sample mean and sample.
Okay, just try to understand now this thing. Okay, so let's say this is having some probability p. So my x is what? Bernoulli p, right? So what does
Yes,
x1 will take? X1 will take either 1 or 0,
one
right?
or zero.
X2 will take values,
One or zero.
right? So
Right.
if I take some one sample, okay, if I take one sample, what will happen? Let's say I got like this 1 0, or
Yes.
so this is my what? This is my sampling one,
But
right?
here you have taken population sample as entire sample.
What have you taken?
Here both the elements of the sample population sample you have taken. So I think it is
Population
not the
sample.
subset.
What do you mean by population sample?
Ajay, X1, X2 you have taken two samples only. Okay. Hmm.
Correct, right?
Right, right. Got it.
So let's say this is x1, this is x2, right? So
Yes,
I'm taking
yes.
two samples. So my sampling one is 1 0, right? Sampling two is what? 1 1. Let's say. In the third instance, what happens? Sampling three is equals to 0 0, something like that. It's because it's random, so we can get any value, right? Suppose I have
Yes.
one like so. Let's say I have four IID Bernoulli sample, right? Okay, again IID X, right? So this will be like this, right? Something like this. So whenever we'll change the sampling, we will get different instances of the sampling. Now you are understanding what it is. So x1 is a sample which is taken from a population whose distribution is like this. You're understanding my point. So suppose this distribution is changed to something else. What will happen? Let's say if I say
Sir, but you can see here from different sampling to sampling, the value of X1 is changing.
correct, right? Because x1 is a random variable, right? It will take
Yes, yes.
it will have different values, right? Otherwise, why we are saying it is a random variable? First of all, if it is a variable, that means its value should be changed, right? And what do you mean by random variable? That means it is randomly changing. So sometimes it is one, sometimes it is zero, because it's Bernoulli. We have only two values to come, right? So suppose it is let's say x is uh, normal 0 1. What will happen? And I said x1, x2, x3 belongs to IIDX. Okay. So in this case, let's say these are the three random variables. I have one sampling. So what are the values it can take? Can take anything, right? So okay,
Anything.
this is normal variable.
It is
So we will have
continuous.
so it can take just a minute. Okay, sampling one. Okay, so it's a normal. It belongs to a normal distribution. It can take which values?
Any value, so
Minus
it can
infinity
take
to
any value.
infinity.
2.3, 4.5, any value.
Right? So let's
Yeah.
say
Yes.
some value is minus 3.2 something. Okay, it's 5.5, 6.5. Similarly, if the sampling two is there, it is having 2.2, 3.3 minus 3.3,
Yes, sir.
like this.
Yes, sir.
So what is happening here? X1 is my random variable, right? The values are changing if I'm changing the samples, right? You're understanding the point. So X1 is my random variable and it takes values according to my population distribution,
Capital X.
correct?
It's yes, sir.
Right? Now
Yes,
you are getting the sense what is X1,
yes, sir.
X2.
Completely understood.
Okay, so that's
Good, sir.
that's how it is happening, right? Now coming back to the problem. So now it's here variance of X1. So what you said, it's not one value, right? This X1 actually takes the different values when I am taking
Yes,
different samplings.
yes,
So what the problem was, at a time it will take one value, correct? But over the
yes, yes,
different samplings, it was having different values, and it will vary across, and it will vary according to the population, right? Because
yes,
variance of X1 and X2, because it is independent and
It will
identically
vary according to
distributed.
X,
Yes,
capital
right.
X.
That's why we said identically. That's why.
Mhm.
So it should vary according to my population. Then variance of X1 will be what? What is this population variance? Correct, right? Now,
yes,
now you're getting the point, right? What I'm trying to say. So so it's not only one value; it is changing. But it's, since it is a random variable, it will change when we take different samples. And how it will change? It will change according to my population distribution. Correct? It's clear.
correct, sir, correct.
Everyone is clear, right, with this?
Thank you, sir.
Okay.
Yes, sir. Yes.
So okay,
Yes,
fine.
sir.
So variance of A is now this is the simple calculation. So it's sigma square plus sigma square by 4. It is 2 sigma square by 4. So it's sigma square by 2. What about variance of B? Again, so you know these formulas, right? You know these properties of variances. So you just have to apply it, and you will get the variance of B as 0.82 times sigma square, and variance of C is, since variance of X2, so which is the greater variance? What is the largest or highest variance? Variance of
C.
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 Then next highest, sorry, next smallest is variance
B.
of B, and then the minimum is variance of
A.
A,
A.
which is sigma square. So which option will be correct? So if I go back,
First, sir.
yeah, so I think, okay. If I go back, it should be option A. Variance of A is less than variance of B, less than variance of C. Done? Okay. Shall we move to the next question? Any doubts in here?
Yes, sir.
Okay. Okay. A fair die is rolled 1,000 times. Let X denote the number of times 6 is obtained. Find a bound for the probability that X by 1,000 differs from 1 by 6 by more than 0.2 using weak law of large numbers. So you're understanding what is this? X by 1,000 minus 1 by 6 should be greater than 0.2. Okay. So this is a statement. Find, and we have to find the bound on the probability by using the weak law of large numbers. Okay.
Done, sir.
Okay, 12 of 21 response I got. Okay, B, B, C, C, B. What is this? How many C's? C, C, C. Okay. So B and C is having. Okay, fine. Let's see the solution. So by vehicle of large numbers, we know that probability that mod of x bar minus mu is greater than delta, it should be less than or equal to sigma square by n delta square. Okay. So in our problem, what is given? It is x by 1000 minus 1 by 6 is greater than 0.2. You have to find this probability, right? And we have to find it should be less than or equal to. So what is sigma square here?
Zero sigma is standard deviation, right?
Correct. What is this?
Sigma square, we have to find as the expected value of x square minus expected value of x square.
Okay, I think okay. So okay. I think that I directly move to the second step. Okay, so first is x denotes the number of times 6 is obtained on rolling the die. So what is x1, x2 here? This is a Bernoulli trial, right? Because our success is getting outcome as 6 and failure is not having a 6, correct? So x1, x2, these are coming from which distribution? Bernoulli distribution, correct? So let's say x1 equals to 1 if 6 appears on rolling the fair die, and xi equals to 0 otherwise. This correct? This okay? This step is clear to all of you?
Yes, sir.
Do you agree with that this x is x belongs to
How
Bernoulli?
you calculate sigma square?
So I'll tell you. I'll tell you. So first of all, did you understand this is a Bernoulli trial?
Okay.
This is Bernoulli trial, right? Okay.
Sir,
Okay.
like what I did is I assumed X to be taking values 1, 2, 3, 4, 5, 6.
Okay.
Okay.
Hmm.
With equal probability. So I think the problem with that is the mu is not 1 by 6, right?
No, right? It won't be 1/6, correct?
So we have to assume a random variable, even the distribution that we are imagining. It should be such that its mu is 1 by 6. Then only we can use
It should not be
this.
assumption, right? It is not the assumption. It is given in the problem, right? So x denote what? X denote the number of times 6 obtained, right? So if you
Yes.
see,
Sir, probability is 1 by 6, throwing a die.
1 minute. Okay, I think you are okay.
Mean of Bernoulli is also the P only, and variance is P into 1 minus 1 by
Yes, yes, correct.
Expected
So,
value Bernoulli.
so suppose
Either we get 6 or not 6. So it will be Bernoulli.
okay, okay. I let listen to me. What I'm trying to say. So y is what? Y. Let's say leave about x. So think this as y. Y denotes what? Number of times 6 obtained, right? In how many time? In how many tosses? In
1000
tosses, right? Okay. So what does that mean? And consider each toss as x1. So consider each toss as one event. Okay. So how many events will be there? 1000, right? Correct.
Yes, sir. Yes.
And y will be what? It will be
X1 plus X2 plus
plus x3 up to
XN.
x1000.
X1000.
Right? N here is 1000. So
Yeah.
y is actually what? Number of times this is obtained, right? So y is a sum of this, sum of these random variables. So there are two ways. You can either consider as y as binomial distribution, because binomial is what? It's a sum of
Number of successes. Yeah.
right. So you can consider it as binomial, or you can consider each x1. So x not consider. We know that each x1 is what? Either we'll get 6 or
not 6.
Not 6, right? These are the two possibilities, right? For each trial, correct? That
Yes.
should be my success or not having success. So whenever I roll a fair die, so consider for the first trial I have rolled a fair die. What will happen? I'll get these outcomes, right? I'll get these outcomes in one experiment. But my success should be when I'll get 6. And since it is a fair die, each will have equal probability, correct? 1 by 6, 1 by 6, 1 by 6, and 1 by 6. This is okay?
Yes, sir.
So having 6, what is probability? So getting the outcome as 6 in each trial is having probability what? 1 by
1 by 6.
Remaining it will be
5 by 6.
5 by 6.
Right? Okay. So y is what? Y is having
So binomial.
binomial. What is n here?
So n is 1000.
1000, 1 by 6.
1 by 6, right?
6.
So I can directly say that I know what is the expectation of y. I can say that it is what?
1 by 6. P.
P,
Success.
right?
P. 1 by
N
6.
into P, right?
Yes, sir.
If you are considering it as a direct binomial, which is a sum of
NP.
right? So I can say it's NP. So it should be 1000 into 1 by 6, and variance of y is equals to what? N into P into 1 minus P. It should be 1000 into 1 by 6 into 5 by 36. So either you can directly go with this way, or consider each x1 as one trial.
6 now. 1 minus P. You write it 5 by 36.
Sorry, 5 by 6. Sorry. Right. Sorry. Okay. So you can use this way also, or you can use so in our case it is already given that x upon 1000 thing, right? So consider x as this thing, right? So x by 1000 means what? Again you are considering only one trial, correct? You are understanding? So what I'm trying to say is, so this mu is what? Corresponding to each trial, right? So expectation of xi equal to mu which is equals to only p, right? Which is 1 by 6. since each xi is a Bernoulli triad, right?
Yes, sir.
And similarly, variance of xi is equals to what? Sigma square is equals to then p into 1 minus p. So it is 1/6 into.
Sir, but in the weak law of large number, we should use variance of x, not xi, right?
Correct. So it is given. So when I divided by 1000, so what will happen when I divided by
Okay, okay.
n?
Yeah,
So
x
it
by
is
1000 will be a random
so
variable.
x by so this will be a random variable. Then this so it is n into 1/6
X by 1000
divided
is
by
actually x bar. X by 1000 is actually x bar.
x bar. Yeah, whatever you can think of. See, that's the same thing, right? So x by 1000. When I am dividing it by 1000, the same thing happened. It is n into p divided by n, right? Again, it will come as p. Is okay?
Sir, here
Ah.
the confusion is because x1, x2 up to x 1000
Hmm.
are not identically distributed as x, right?
Why not identical distributed? They are identical distributed.
As x.
Huh? It's okay, right? As x or some.
X is binomial distributed, sir, and they are
No, no,
binomially distributed.
no, no. X is not. Okay, sorry. So
X1 to x1000 is a sample obtained by rolling the die
it
1000
is
times.
okay. This x, right?
So
This x given here.
is a
This is
sample.
this is a not. This is not a sample. This is a sum of.
Yeah,
It's
so
a
it's
sample of
maybe some
1000.
another variable should have been used for it to
You can think. So
avoid the confusion.
think it as xi is belongs to some, let's say, some IID, some z or something, right? And with z
Yeah,
is
yeah.
z means it's a binomial.
That's why I got confused, sir, because x
No,
is
no.
used and
See, that's what you don't go with the notations. You can think of separately. You can think of as conceptually. So then this x actually is not a population. This x is what? It's a sum of IIDs, right? And this x by 1000 is x bar actually, right?
not
This is
x
another
bar,
random
sir.
variable.
So let's
Or,
take that identically distributed as z.
yeah, this
Then we
consider
can
as
go.
z.
This is
not
z
x
bar
a
then.
sample, sir. Is not x a sample. We are rolling the die 1000 times and we are obtaining one sample. And out of this 1000 samplings, we are considering how many are 6. So x by 1000 is actually x bar. And x bar, the mean of x bar is 1/6. So we are subtracting x bar from 1/6. So that's where the Chebyshev's comes
Correct.
here.
That's right.
Chebyshev's comes here.
That's right. That's right. Right?
Sir, if we take like x1, x2, x3 up to x1000 identically distributed as z, let's say, then x by 1000 is z bar, right?
It is identically distributed to z. Okay, that is also fine. It's not a problem. See the notations and it does not.
That
as
is
far
z
as-
bar, na sir?
Okay, z bar you can think of. It's not a problem, right? It's a sample mean. Just consider a sample mean.
But it is not x bar. X bar is different thing, right?
What is x bar? What is x?
X is the sum of the samples in a
Okay,
sampling.
okay. Let's say this. Okay, don't think it this as x. Okay, this think as y. Y is the sum of thing. Okay.
Yeah.
Why you are I don't understand. You are confusing with like y by 1000. If I say, what does this mean?
This
Y by
means
1000 means was it is x1 plus x2 plus x3 plus 6000 by 1000, right?
yes, it's the mean of that sample.
Yeah. So consider as whatever notation you will.
Yeah.
You wanted to
Now it's
put,
okay,
it's
sir.
not a problem,
Now it's
right?
okay. X bar.
So
If you
why
take-
I'm saying this entire numerator as y. Okay, or I can say it as x also. Notation does not matter here. What does matter here is what is that mean, right?
Yeah.
What that x by 1000 written there is meaning. So that meaning is x equals to x1 plus x2 to x3 to x1000 divided by 1000. So it again it's a sample mean.
Yeah, it's sample mean. Okay.
Right? Okay. And mu will be what? Mu will be population mean. Correct? So it comes from here, right?
Yes.
So from the distribution. Okay. So let's
Mu of
Sir.
sample mean is the mu of sample mean is also the same as the mu of
Population.
distribution. Yes.
Because it is very easy to derive that thing, right?
Yes. Yes.
So
Yes.
here you have taken expected value of y as population mean.
Okay,
Population
okay.
mean will be expected
I
value of
think
x1,
I
sir.
should. Okay, so why you okay, so x1, okay, let's consider x1 x2 to x,000 are coming from some IID x, right? IID x is what? It's Bernoulli. How much it is? The probability of success is 1/6.
1/6.
Okay, is okay. Okay. Now the sample mean is what? X bar is x1 plus x2.
x1 plus x2 x1000 upon 1000.
Okay. Why I was saying that consider this sum as a new random variable. Okay. So I just wanted to write this as like this, y by 1000. Do not get confused, but again you are confused with the same thing. So I'm just
What is mu here, sir? What is mu?
mu here also what? It's very simple, right? So you just not. So don't think of this. Okay. Remove this y from your head. Now it is x bar equals to x1 plus x2 to x,000 by 1000, right? To find the mu, what do you have to do? It is, or mu is what? Mu comes from what? What is mu? Mu is population mean, right?
Mean.
Okay.
Yeah. So expected value of x.
So expectation value of x, right? It will come from the population. So population is having what distribution? Bernoulli distribution.
Bernoulli 1
So
by
what is expectation of x? Which is mu, right?
Yes, sir.
And what is variance of x?
Mhm.
It is
P
1 by
square.
6 into 5 by 6, which is sigma square.
P into 1.
Right?
Yeah.
Okay. What is sample mean?
Sample mean is this only, no, sir?
So it is actually
1 by 6. 1 by
expectation
6.
of x1 plus x2 up to x,000 divided by 1000.
1000.
Right? Is okay? This step is okay? Okay.
This last one, sir, I got
Which one? This
confused.
one? See, x
Expectation.
bar is this, right? X bar is what?
This is sample mean. This is a sample
Okay.
mean.
X1 plus x2 2. Okay. What is expectation of x bar? That means expectation of x bar means if
I understand that across different samples you are taking the mean of the mean.
Okay.
Sample mean.
Right. Now with the properties of expectation, I will take one by, because this constant is there, I will take it out. Inside it will become expectation of x1 since they are independent, right? So I can write like this up to, fine, is okay?
Yes.
Okay.
Yes.
Since, okay, again expectation of x1 is same as expectation of x, right? Okay, so it is one, and again x1 x2 x3 are again identically distributed, so I can say n times, that is 1000 times mu,
expectation of x,
right? Or yeah,
mu.
So this is 1 by 6. This will go away, so it will become 1 by 6, which is again comes to the
expectation of x. Yeah.
Right. Similarly, you can prove for variance. If I wanted to find variance of x bar,
yes, sir, that
sigma
we have
square
done
by
that. Yeah.
So it is 1 by 1000 square into 1000 times variance of x, right? So it is variance of x divided by 1000. What is variance of x? It is
5 by 36.
5 by 36.
5 by 36.
Correct? This is actually this is sigma square by n, right? This is how it actually comes from. Right now, by weak law of large numbers, we are going to find for probability that x bar how much my sample mean deviates from the population mean, right? What is the probability that it will deviate from that some delta? This is given by what? Weak law of large number. This is basically what you studied for. I forgot the name of Chebyshev inequality, right? This is a Chebyshev inequality, right? What is Chebyshev inequality? Probability that x bar minus mu greater than some delta should be less than or equal to variance divided by what? Delta square, right?
So, sir, excuse me, sir.
Yes, sir.
Sir, for the variance, we will be taking for individual random variable. Okay, and we will not be taking as a whole.
No, we are taking
Number
the
of
It's
whole.
population mean,
Like,
and since population mean is identically distributed as all the single variables, so that we
yeah.
can take.
Okay, thank you.
Yeah.
You are understand. So it's a sigma square by n is actually for the all sigma square by n, right?
Okay, sir.
Okay. You are understanding? You understood, or you're just saying okay?
Sir, I just
Understood,
want
sir.
to know,
Totally understood.
because
No,
since we
Malik.
are taking every random variable and we are calculating for the total number of 6 that are occurring in 1000 dice toss,
Hmm.
why we are not taking the variance as 5000 by 36? Why we are taking 5 by 36?
Okay. No, it's not 5 by 36. It is 5 by 36 by 1000.
No, sir, that is the formula because we are taking
No, no.
sigma square as
Okay.
5 by 36. The variance is 5 by 36.
No. Okay. What is x bar here?
So xy 1000 or
No, x
x1
bar.
plus x2 plus
Ah,
1000
right?
divided by
Okay.
4. Yes, sir.
1000 by
1000.
1000. Okay. I wanted to calculate the variance of x bar, correct?
Yes, sir.
Okay. So it is what? Variance of x1, x2, x1000 by
1000.
okay. So it will become 1000 square
1000 square.
into variance of x1 plus variance of x2 up to variance of x1000, right?
Yes, sir.
Okay. Since they are identical distribution, I can directly write it as 1000 times variance of x, right?
X. Yes, sir.
Okay. So this is what variance of x divided by
1000.
what is 1000 n, right?
Yes, sir.
It's correct.
Okay, sir. Now I got
So
it, sir.
this is variance of x means what? Sigma square by n.
And
My formula is probability that x bar minus mu mod of x bar minus mu greater than delta should be less than or equal to variance of x divided by what?
sigma delta square.
Or variance of x bar upon delta square, right?
Yes, sir.
So it is what? Sigma square by n delta square. So the sigma square by n. This
Okay,
is what variance of x bar. So if you can
sir.
think
So
of
it
this
is
is sigma square by n. So it is
Chebyshev.
5 by 36. Yes.
Yes, sir.
5 by
So we are
36.
just
Right?
Sir, one
okay, sir.
observation
Got it.
here.
So it is for Chebyshev inequality, but for identical random variables.
Yes. So
Sir,
huh.
one
Okay,
observation
sir.
here.
Thank you.
X by 1000 can never be negative, right? So 1 by 6 is less than 0.2. So this absolute value, I mean, this the number in this absolute value will be always greater than. I mean,
yes, so the delta should be positive, right?
yes. So
That's why it is given
it cannot go to the opposite side. It will always be towards the positive side.
anyway we have
It's
taken the
greater
absolute
than
value, right?
0.2.
Yes, but it is always since you know we have taken the mod of it, right? So
Yes.
absolute value cannot be negative, correct?
Yes.
Right.
But even if it is negative, it will never be greater than 0.2. Even if it is negative, the mod of this value will never be greater than 0.2 because x by 1000 is never 0, less than 0, and 1 by 6 is less than 0.2. So x by 1000 by 1 by 6, even if x by 1000 is less than 1 by 6, the mod of this value will never be
Correct.
greater than 0.2. It will
That is
always be
correct.
less than 0.2. So
No. Somewhere you are missing that 0.2. Actually, it's a delta, right? It's an arbitrary thing,
it's
right?
a number 0.2, but x
You
by
can
1000,
you can just say that x by 1000 minus 1 by 6 of mod.
1 by 6 is something around 0.17.
Okay.
0.17,
Hmm.
and x by 1000 can never be less than 0 because it's a positive quantity. So if x by 1000 is less than 0.17, the subtraction, even if the subtraction will be negative, but the mod of this subtraction will never be greater than 0.2. So x by 1000 will always be greater than, according to this inequality, x by 1000 will always be greater, this probability x by 1000 will always be greater than 1 by 6. And it will be greater than 1 by 6 plus 0.2. Are you getting me, sir? See, 1 by 6 is 0.17 and x by 1000 can never be less than 0. So x by 1000 by 1 by minus 1 by 6 will never be, the absolute value of this number will never be greater than 0.2, because 1 by 6 itself is 0.17.
Why not? So let's say x is equals to what? X is what? X is a
X can never be negative, sir. It's the number of times.
no. 1 minute. X is what here? X is sum, right?
Yes.
Sum of all 1000 IIDs, right? So suppose x will take values. What values it can take actually?
It can take all positive values. So let us say it is 0.
It's a number. Okay, what is x?
Zero.
Okay. No, just a minute. Okay, what is x? It's a number of times 6
has occurred. 6 has occurred.
So in 1000 tosses, how many times?
No 6 has occurred.
No. Don't consider 0. What you are saying, it cannot be greater than 0.2. You're saying, right? That difference.
If it is less than 1 by 6, it can never be greater than 0.2. Because let's say even if.
But I don't understand. Okay. What your point
is? Less than 0.2. This mod quantity in mod should be less than 0.2.
Why?
Greater than 0.2. Greater than 0.2. It should be greater than 0.2.
No, less
it
than.
Can be greater than 0.2 as well as less than 0.2, and we are trying to find the probability.
What is probability, right?
Probability greater than
0.2.
I don't understand your point. Why you are putting that point here? I don't get it. But the thing is, it can be greater than or it can be less than also 0.2, right? This thing. Why you are not saying that it should not be less than, it should not be greater than 0.2? I don't understand. So when x equals to 1000, it will be 1 minus 1 by 6. So that value
that time it will be positive, so it's okay. But suppose that x by 1000 is less than 1 by 6.
In what case? Okay, in what cases it will be?
Suppose x is say 0. Then
x is 0. Then
this quantity is minus 1 by 6.
Which is again?
Which is the mod of this will be 0.17. 0.17 is never greater than 0.2. So even if x is 0, the mod of this quantity will never be greater than. So we are talking about always x by 1000 greater than 1 by 6 by 0.2. According to this probability, we are talking about x by 1000 greater than 1 by 6 by 1.2. So x by 1000 greater than 1 by 6 plus 0.2.
So what is the point of this?
So normally we are talking about two tails, sir. A positive tail and opposite side normal distribution negative tail. But in this case, we cannot talk about a negative tail. We cannot talk about x by 1000 less than 1 by 6, because x by 1000, even if it is less than 1 by 6, it is never going to be greater than 0.2. X by 1000 will always have to be greater than 1 by 6 for this probability to occur. If it is less than 1 by 6, then this mod quantity will never be greater than 0.2. It will always be less than 0.2. Maximum, minimum value.
Okay, let's stop. Okay, I understand somewhat. I'm not sure completely why you are like. So it is like what we are saying, that if this sample mean is like is the difference between the sample mean and the population mean, if the absolute difference actually, if I say if it is greater than 0.2, what is the probability for that? It is this one, and it is very less actually, right?
Yes.
So for very large values of x, you will get this difference greater than 0.2, and hence this probability is very less.
Yes.
Okay. So yeah, so maybe yeah, you're talking about something else. I'm not sure. Like, uh, okay, let's stop this. Then we you understand, right? What is this actually? So
Hmm.
what you're trying to say?
Yes,
So
this question I understood.
okay, then it's fine. So shall we move on to the next question?
Okay.
It's okay.
Hello, sir.
Yeah.
Sir, actually, difference between sample mean and population mean.
Hmm.
What is its meaning? What meaning
I
of
think
this?
one of the sessions when I was talking about Chebyshev inequality and the Marcos inequality, I told the intuition behind it. So the Chebyshev inequality means since
Yeah.
when you're actually drawing the samples, right? The sample mean for that sample, it will not be the same as that of the. It will not always be the same as that of the population mean, right?
Population,
So,
yes.
so what you are doing actually, you are not taking one sample only, right? You will be taking a lot of samples, and you are finding the sample means. So the distribution of this. So again, that sample mean will have a. It's another random variable, right? Sample means another random variable. You're
Yeah.
understanding? It will have one distribution. The sample mean will have its distribution. So the
Okay.
mean of that sample mean how much it is differing from the population mean that we are
Okay.
actually finding out. Okay.
But sir, in case of centralized distribution,
Okay.
uh, uh, sample uh, distribution mean is zero.
Okay.
Then, 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 what we interpret difference between population mean and sample mean. In that case,
Okay. So what do you mean by centralized distribution?
yeah,
So
yes,
what you're doing actually, uh, let's say one case, simple case, Bernoulli case, right? Bernoulli P is my
yeah,
case. In that case, what will happen? Okay, so those who are, uh, please solve this question. Okay, we are discussing this question. We just
okay,
solve this question. Okay, so let's suppose Bernoulli P. What does this mean? It will have a mean
P,
at P, right? Mean at
yeah,
some probability value. Okay.
yes,
Okay.
yes,
Now I just wanted to shift that mean to zero. So I am
okay,
actually shifting that population mean to zero.
okay,
Okay. I'm not shifting the sample mean. I'm shifting the population mean to zero. And how will I do that? I will subtract that P from each observation of the population, right?
population mean, okay,
And if I do that, I know that if I do that, definitely the mean, because the property of mean is what? If you are subtracting any value from the each observation, the mean also will what? Get shifted towards the left, right? Or you can say
towards the
that,
left,
Yes, sir.
right? So or
towards the,
if I, yeah, so because if you record from the stats one, we used
yeah,
to find, the new mean equals to old mean minus constant. The
yes,
new
yes,
mean
sir.
equals to old mean plus constant. If I add that constant into the each observation, right?
Yeah, yeah,
So so in that way we are saying that, uh, assume that if I have subtracted a constant which is equals to p from each observation of the population, what will happen? My distribution will change to, so my distribution will shift to zero. The distribution mean will shift to zero.
sir. Yeah.
Okay.
Okay, sir.
And then again I'm going to take samples out from the distribution, the modified distribution or the centralized distribution.
Okay,
Okay.
okay.
So try to find answer for this question number three. So here also I don't think it is too difficult. Let's try to solve this. Okay?
Sir, this will by definition remember, like
Which one?
it will be 4, right?
Sorry, I no. What?
Like by definition we remember, like
Which one?
this question.
With definition of, like, if you wanted to find expectation of x square, you have to just what you have to do. You have to
We
say
know that
expectation of, yeah.
expectation of sample variance gives us the population variance.
Okay, you by definition, but okay, if you don't remember the, okay, I don't remember the definition, for example. So what I'll do, I'll just
We'll
use
use the
the,
expression to
yes.
solve this.
If you do that also, I think it's really possible, right? Yeah. Okay, however, it's fine. Like, if you know it, it's good only. Shall we see the solution for this then? Because I don't think
Yes.
it's a difficult question to. Okay, let's see. So yeah, this is how you have to solve. You have to just open the bracket. So expectation of x square, and if you remember it also is fine. If not, it's okay. So expectation of the sample variance, it should be equal to the population variance, right? Okay. But if you don't remember also, you can just use this. You can actually open the bracket. So what is how does the formula is going, right? Okay, fine. So x minus x bar square plus 2x6 minus x bar square, and it is. Shall I solve this, or is it okay? If anyone wants, I just can solve this.
Sir, can you solve, please? I could not understand as professor solved this.
So here, this, no, by looking at the solution, you are able to like connect it, or
Yes, sir. In the last line, 1 by 5e6 x bar square.
okay,
then,
fine. Okay, I'll do.
Where I miss and confused.
Okay. So what is s square? S square is equals to x1 minus x bar whole square plus x2 minus x bar whole square plus 6 minus x bar whole square divided by n minus 1, right?
Yes, sir.
So here n minus 1 is 6 minus 1, which is equals to 5. Now if I wanted to find expectation of s square, it will be expectation of this, right? This entire term, correct? Okay.
Yes, sir.
So by properties, so this 5 is what? Constant. So I can say 1 by 5 outside. Then it will be expectation of what? x1 minus x bar square plus expectation of
x2 minus x bar whole square.
Okay. So since, see, how I am able to write this is because x1, x2, x6 are IID random variables, and x bar will be always be constant, right? So
yes, sir.
Right. Okay. Then it will be like this. So I can write like this. Fine. Okay. And whole 1 by 5 outside. Okay. Okay. Now if I open this bracket, how it will be, or else what I can do. Okay, fine. So let's say
for x1, right, sir, x only. X1, x2.
So it will be expectation of x1 minus 2 x1 x bar, correct? Plus
x1 square minus 2 x1 x bar.
Okay.
Plus x bar.
Right. Plus
x bar square.
X bar square. Okay. A similar thing will happen to the next terms also. I'm not going to write now.
All our IDs, so we take some summation.
No, just wait. So I'll just open up this first. x1 square, right? Minus 2 times
x1 x bar.
x1 into x bar plus x bar square. This is okay?
Yes, sir.
Yes, sir.
This is okay, right? And
Yes.
so other terms, actually, I'll
Sir,
write it as
why x bar is constant, sir?
sample mean,
Since
no? Sample,
but
sample.
x1 is changing, x2 is changing. We are moving across the samples, na sir. That's why.
But,
X square is
but for
constant.
any sample, x1, x2, x3, x4, the x bar
Every
will always
for
be.
single samples, everything will be constant. We are moving across different samples, right?
It's okay. So it will be constant, right?
Sample mean will change, na sir, for across different samples. Population mean will same, but sample mean will change across different samples.
Yes, sir.
Whatever
How
it is
can we
changed,
say x bar
it
is
is
constant?
always constant, I think.
It is not. See, it will be a constant because what is x1?
So it is IIT
X1 is,
इसलिए.
X1.
X1 is one observation from the sample.
Okay. So this x1 is one observation, x2 is another observation, x6 will be another observation,
Yeah.
and divided by 6. So it will be a constant for that x1, x2, x3, for x, right?
Yeah,
For
for
one
that
sample,
sample it is constant.
it is constant, right? It is not varying, correct? So I'm
But
just.
if I take another sample, x1, x2, x3, x6, all will change.
It's okay,
So will
right?
change the x bar.
Yeah, that's fine. That is okay.
But for
Where I'm doing
one
mistake,
sample, x1 is also constant, and sir, x2 is also constant. How can we treat them as variables? For single,
I'm not considered as a variable, no.
so why we are trying to find expectation of it, sir? If x1 is a single value,
I'm finding
constant number.
expectation of xi square, right?
Sir, I do not understand. Like x bar is constant. If x bar is constant, then x1, x2, x6 all are constant. If they are not constant, then x bar is also not constant. We are treating one as constant and one as variable. This does not make sense, sir.
So okay, how did you find that? How you directly solved this expectation of x square as variance of x, right? X
So
bar.
I just remember it from the lectures that
Then
expectation.
while doing that, while seeing the lecture,
I do not understand the proof very well, sir.
okay. So I'm not sure. Like okay.
But I think my question is like reasonable. I think.
No. I'm not talking about like okay. What the question is okay. Every question is reasonable only. But I'm just trying to see like how to explain to you like why I'm going to say this. Okay, let's think. Let me think once.
So this S square is the definition of the sample variance, right?
Correct.
So we are trying to find the expectation of this sample variance. So that's why we are considering both x as well as x bar as random variables. And then we are trying to find the expectation, and then we are expanding that, and that is how we are finding. So x and x bar, xi and x bar, both are random variables. X bar has the mean as mu, and variance as sigma square by n, and x has mean as mu and variance as sigma square. So that is how I understand. So
that is right.
Yes. So x bar also we have also understood like expectation of x bar itself we have studied, right?
Correct.
So x bar is a random variable and
correct. So, I made the mistake here. Yeah. So it should be okay. So x bar should also be a random variable, right? Yeah, that's true. So expectation of x square is equals to what? Expectation
1
of
by 5.
So 1 by 5 will be outside. Then expectation of okay, x1
Summation
minus.
we are expanding that now.
Yeah. So maybe I'll do that again for everyone. So it should be like this, right?
So I think we do not need to like break first it into.
No, maybe a lot of people don't understand that summation thing. If you are fine with it, I'm okay with like.
No, sir. I'm saying just break it after. First expand. First open the squares inside only.
Okay.
So that we can write it as x1 square plus
okay,
x2 square.
Okay, that is also.
That's what I'm saying.
Right. Let's say expectation outside. It should be, so first bracket will be x1 minus
X1
2x1 x bar plus x bar
Sir,
square.
x1 square, sir. X1 square.
Yeah. X1 square, right? So here it will be x2 square minus 2x2
x bar.
2 x bar
And so
plus x bar square plus like this. So this is x1 square plus x2 square plus x3 square up to, so it will come, right? So it will be expectation of x1 plus x1 square
plus x2 plus
this 6 terms will be there. Then the middle terms will be what?
Minus
2
we can take.
Okay. So
2x bar. 2x bar we can take common.
And inside it will be x1 plus x2
up to
x6, right? And the last term will be 6 times, right? So x bar square, so it will be
6 times x bar square.
6 x bar square, right? Okay.
Yes.
So this x1 plus x2 to x6 square, I can write in the compact way as summation of I go from 1 to 6
xi square.
Okay, xi square. Okay. Similarly, this term in a compact format, how will I write? It will be 2x bar outside into summation of xi equals to 1 to 6 xi, right? And the end answer will be 6
x bar square. And we have to find expectation of this whole expression.
Okay.
Yeah.
Okay. So it will be up to this point is okay, right? Okay. It's
Yes.
1 by 5 into
expectation of the individual xi squares which are all equal.
Now we can break
expectation of individual xi squares which are all equal, because
xi square
right.
Minus.
Okay. Let me write
minus
2
times expectation of
summation of xi is equal to x bar into 6, sir.
Yes, this term also I can actually say that because x bar can be written as summation of I equals to 1 to 6 xi
divided by 6.
So I can write it as
6x bar
2 times x bar into
6x bar
into
12x bar square it will become, sir.
2x bar into
6x bar
into 6x bar plus
6x bar square.
Okay. So the next thing is
so that some expectation thing I think you missed a bit.
Okay, yeah.
This is still inside expectation.
So I'll do it later on.
Yeah.
This is 1 by 5. Now I can write it as expectation of summation of I equals to 1 to 6
xi
square. Okay. Minus
expectation of
12 expectation of
x bar square.
And again, okay, so 6x square
minus 6 it will become, no, sir? Minus 6
expectation of x.
Okay. And this expectation of x square, actually, I can find it from variance of x bar, right? Variance of x bar equal to what? Expectation of x bar square minus
expectation of x bar cos square.
So I can actually write this as
so expectation of x bar is
1 by 5 side should be expectation of this summation of 5 goes to 1 to 6 x square, right? Minus 6 times what?
Okay. Variance of x bar is sigma square by n.
Variance of x bar
plus
plus
expectation of x bar.
X bar square.
Okay. I think it's okay. So you can just plug in the values, I think. So here it is written this thing, right? Variance of x bar plus expectation of x bar to the whole square. You can just variance of x bar will be sigma square by n, right? As 4 by 6 plus 15 square. What about expectation of xi square? It is again individual.
They are all equal, sir. All xi
Yeah,
square expectation
correct.
is equal.
So it is 6
And that
times.
is mu square plus sigma square.
Correct.
Sigma
So,
square plus mu square.
so 6 times 229, right?
So please xi square if you can tell once more.
So it is okay. Suppose don't think about summation here now. So for each xi square, I can say that expectation of xi square is equal to what?
Variance of x.
Variance of xi
plus xi
square.
plus
Sorry, variance of xy plus
expectation of xi
whole square, right?
Yeah.
And they are same
So
for all the.
they are same. So it is 6 times this quantity. Variance of each xi plus expectation of xi
Yeah.
square. So variance of xi, and what is variance of each xi? So
it is same as variance of
4.
x bar.
Same thing. Right?
Yes, sir.
Sir, why 6 into? Why you have multiplied?
Because it is sum, right? Sum of. So for x1, what is this? For x1,
For
it
x1.
is.
Yeah.
For x1, it is.
It is equal to xi. X1, x2, x3, sir, all are same because it is IID. So the variance of x1 and variance of x2 and variance of x3 is all
So it is 6 times variance of this, right? 6 times all these terms. Correct?
Variance of x. Okay.
Okay.
Yes.
Done. Shall we move ahead then?
Yes, sir.
Okay.
Well, here. So
We have
can
completed
you-
this, right? Okay. Same. What
So
happened?
here, E xi square, we write it variance of xi plus e to the power xi. This is okay. But here in es square, expectation of x square, we write 4 by, you write it 6 comma 6 in bracket 4 plus 2 to 5.
Yeah, so this 4 plus 15 square is 4 plus 2 to 5, right? So actually you can say 6 into 229. So how does that 6 come is? So each xi means what? For x1, then x2, then x3, because I will vary, right? So how many i's I will go? 6. And since they are identical, I can just write 6 times expectation of x1 square, or maybe whatever, x1 or x2 square. You're understanding?
Yes, sir.
So it should be 6 into 229. That's it. Done? Okay. So here, what is the change? I'm not sure. Like, is it the same question, or this looks like same question, right? Yeah.
Yes, sir.
Same, sir.
Same.
So it is not same, sir. The
Same.
No, sir.
denominator is 6, sir.
S x bar is
S square by
Okay,
6.
so a square actually it is 1 by 6.
Yes, sir.
Okay, somewhat little difference. Okay, just try it loud. Try it out. What? Just try it. So the same thing you have to use, but this is not directly. So if you remember the direct formula of sample variance, this will give you the wrong answer now, I think. So because this 6 is there, right? The previous problem it was 5. Just try to solve it in like take 5 minutes and try to solve this question. Similar kind of question is there. Okay.
So show the calculations for the previous one, so we can just plug in the values.
Okay. So why? So very few. I'm seeing like very few. Sorry, very few answers. Only 8 out of 23 have responded. This is a similar kind of problem. It's just like that 1/6 outside will be there, right? So other terms will be the similar. Only whatever value you got in the previous question, you just have to divide it by 6 instead of 5. Right? That is the only difference actually. So okay, shall we move to question number 5? I think this will be last question. Okay. Okay. So the question is, am I audible?
Yes, sir.
Okay.
Yes, sir.
So question 5 is a random sample of size 100 is collected from a population P, where P belongs to a distribution uniform 0, 20. Okay. Find an upper bound on the probability that the sample mean will be at least 2 away from the actual mean using the weak law of large numbers. So you have to use weak law of large numbers to find the upper bound on the probability. Okay. Okay. So what will be delta here?
2, sir.
2.
Now try and solve it. Okay. Okay, so shall we see the answer, or anyone wants some time to solve it? Most common answer is 0.8. Okay, 0.083, and there are certain answers who are 0.95, 0.917, 0.95. Okay, fine. So shall we see the solution then?
Yes, sir.
Okay.
One minute.
Okay. So if you want time, okay, just take it. Done?
Yes, sir.
Sir.
Okay, so we'll see the solution now. So it's delta here, it is 2, and uniform distribution. So what will be the value of mu? The
Mu
population?
is 10.
Mu will be
10, sir.
10.
10. 10.
So here, and n equals to 100, right? So just by using the weak law of large numbers, mod of x bar minus mu greater than 2 should be less than or equal to variance of x square, sorry, variance of x bar divided by delta square, right? So delta square is, here it is 2 square. So sigma variance of x bar is sigma square by n, right? It's okay, right? And what is sigma square?
Yes, sir. Yes, sir. Yes, sir.
Sigma square is b minus a to the whole square by 12, right?
Yes, sir.
So it is 20 minus 0, the whole square by 12.
400 by 12.
400 by 12. So 400 by 12 divided by 4 into 100. So if you solve it, the answer should be 1 by 12. So I think 1 by 12 will be closer to 0, right? Not to the 1. So those who have answered, yeah, so it should be around how much?
0.083, sir.
Yeah.
0.0.
It is near to 0.1 value. So those who are
0.083 it is.
0.083, the precise answer should be 0.083. Yeah. So that should be the correct answer, right? Okay. So that's it for today. So I think we have covered the problems from the weak law of large numbers, right? So most confusion happen in this week is the sampling sample, I think, right? So what is x1, what is x2, or what does that sample mean, or something like that. I think we have covered maybe some of the questions from this grade assignment also, along with this solve the slides, right? Okay. So,
Sir,
yeah.
what's your name, sir, actually?
What's the name of?
What's your name, sir?
My name is Mayur.
Yeah. Mayur. Okay,
Yeah.
okay, sir.
So, okay, that's it for today. Okay. So,
Okay, thank you, sir.
okay, thank you guys for joining.
Thank you,
Good
sir.
night.
Thank you, sir.
Thank you.
Good night. Have a
Please
good day.
upload the slides.
of this session also. This session it was not that good, right? Whatever I written, it was.
No,
But if
the
you,
problem and answer is there. That's why.
okay, okay, I'll upload.
And also 5
Peer
and
deck
6.
slides, sir. Peer deck
PRDX
slides.
slides, so PRDX slides definitely I'll share. Okay, okay.
Sir, quiz one result.
Is yet to come. So maybe you'll get okay. Today I think they have signed up the results. Maybe in 1 or 2 days, maybe by Tuesday or maybe tomorrow also it can be released. But in worst case, you'll get by day after tomorrow. Okay. Okay, guys. Good night. Thank you for joining the session.
Good night, sir.
Deadline is extended now.
Yeah. So that confirmation is not there today, but Shrikant said that he will talk to the team and then they will decide. Okay. So most probably it will get extended. So no worry about it.
Sir, one more question. Where can we find these values, probabilities, cumulative probabilities, cumulative distribution function for